Okay, so I'm about to use Universe Sandbox to show to you a newly discovered exoplanet or extrasolar planet named Alpha Centauri BB. Now the reason why it is named BB, it's because the parent star is called Alpha Centauri B, and I'm pretty sure you've heard of this star. It's actually one of the closest stars to our own solar system, and so far among the many exoplanets already discovered, there are over 800 of them. This one has the smallest mass. In fact, it's just 1.13 times heavier than our own planet Earth. This is probably why in most media circles it's being referred to as the new Earth, or like Earth-like planet. But as I'm about to show to you, once you realize the characteristics and the orbital parameters of this planet as it goes around its parent star, which is Alpha Centauri B, you'd realize that it's a far cry from an Earth, considering the conditions that will be experienced when you land, if it's even possible to land on this planet. So here we go. We're going into Universe Sandbox. Okay, so to begin this demonstration, I'm gonna load up Universe Sandbox here, and to save time, what I'm gonna do basically is just load an existing simulation of the Alpha Centauri binary system. As you can see, it's here, System Alpha Centauri. So Universe Sandbox already comes with this file. It's a simulation of the Alpha Centauri system, so I'm going to open that, and here you can see Alpha Centauri A and Alpha Centauri B, the two stars, orbiting each other, and they're basically going around the common central point. I'm going to move my mouse and select Alpha Centauri B because that's going to be our focus star, and we're going to add a planet. So there is a tool here called an add tool in Universe Sandbox, and it shows some sample planets. So since we're dealing with an Earth-like planet, it's logical or obvious to choose the Earth, and we're just going to drop it very, very close to Alpha Centauri B, the star. And the reason why I want to drop it as close as possible is because according to the data that we have about this new planet, it's actually orbiting Alpha Centauri at quite a rapid rate because of the fact that it's close. So I just dropped it, and we're going to edit the parameters of this object. Like, of course it's not the Earth, so let's change the name to Alpha Centauri BB, and the mass is actually 1.13 Earth masses. You can see a velocity vector there and the orbital path, but that's going to change because I'm going to change eccentricity to like almost 0 or 0, so that we'll have a uniform circular, almost circular orbit. I can also change the inclination a bit. We actually don't have the data yet for the actual inclination, orbital inclination of this exoplanet, so it doesn't matter. And what else? Period node. Okay, so this is the most important part. The orbital period of this exoplanet is actually less than that of Mercury. Mercury orbits the sun in like 88 days, but this planet is like faster than Mercury because it actually orbits the parent star Alpha Centauri B in just 3.2 days. So as you can see, the orbital path made this line that went directly to the towards the planet star, and as you can see now, it's actually orbiting Alpha Centauri B in a very tight circle. And now let's move to the arrow tool and see how Alpha Centauri B, now our focus has changed to Alpha Centauri B. And there, we're up close. And as you can see, it's actually rotating, but that's actually wrong because it's supposed to be tidally locked. So what we can do is change this part and tidal lock. So what does this mean? It means that one side of the planet is constantly facing the parent star. Because of its extreme close distance towards the star, this could be a property that is inherent with planets that orbit very close to their parent stars. And one last detail would be some details of the planet itself. Let's not give it an Earth-like texture because of the fact that it's so close to its parent star. Scientists and astronomers, planetary geologists predict that it could have a molten surface. So let's change the texture and find out if we can get a yeah, that looks good, and change the color to something molten, like maybe red. Oops, not there. There we go. So here we have a more accurate artist's illustration, if you will, of Alpha Centauri BB orbiting Alpha Centauri B. And zooming out, or well, I don't have to zoom out much, but let's move time down. Let's pull it down a bit so as to slow things down, and try to find the other star, which is Alpha Centauri A. Where is it in relation to this whole arrangement? Oh, there it is. There's Alpha Centauri A. It's kind of difficult to imagine both stars at this being seen on the surface of this planet at the same time. There could be a particular configuration that this will happen, but right now I cannot find that configuration. It's kind of difficult considering that every parameter like orbital inclination and actual tilt of this planet is unknown, so we cannot really get a good angle to envision the usual artist's conception of like a sky having two stars in the sky, or like, but in this case it's clear to see that there's going to be one huge star in the sky, one huge sun, and that will be Alpha Centauri B, and nearby will be a smaller bright star-like object, and that would be Alpha Centauri A. Let's try to zoom in. Here is a cool scene of Alpha Centauri BB and Alpha Centauri B, its parent star. So I hope you enjoyed this session, this simulation session, and as you can see, it's from the graphics that we have here, this system is far from Earth-like in many ways, because of the fact that it's Alpha Centauri BB is very close to its parent star, and of course the surface is really molten because of the heat. Scientists and astronomers predict that the temperature on the surface would probably be something in the neighborhood of 1200 degrees Celsius. Venus, on the other hand, the surface of Venus is at around 460 degrees Celsius, so it's almost like about 3 times hotter than the planet Venus. So again, I hope you enjoyed that simulation, and hopefully next time I'll show you another kind of exoplanet system if more details or more data arises.